So now we are on page 66, and we're going to look at your first assignment in the book. This is page 66. I'm going to assign you 7 through 43 odd, I think. Yeah, 7 through 43 odd. So I want to go through some of these even ones and show what I want you to do with them. So for example, when you pull down the book from the website, it's already going to tell you the answers right here. So you already know the answer to number 8 is 1. All right. I'm not interested in knowing the answer is number 8 is 1. So don't just put 8, 1. Okay. You have to justify that and explain why. All right. So, and also, in order to do that, we need to understand this direction. It says determine the limit by substitution. So by substitution means if when we plug in the limit value, what we get is not undefined, then we can just do that. So the only time we can't just plug in this limit value and get a result is if the function would be undefined. So for example, in number 16, if I try to plug in x equals 0, I get 1 over 0. It's undefined. I need some other way to find out what that limit is. In number 18, if I try to plug in x equals 0, I'm going to get 4 plus 0 squared is 16. 16 minus 16 is 0. Denominator is going to be 0. Whole thing is undefined. So I'll need some other way to evaluate the limit. But if you plug in the value and you don't get something undefined, then you can just say that that's the limit. And I'll show you how you justify that. And also, it's the first thing you should always check. So you might see this limit right here on the AP exam. What's that limit? The first thing you should do is plug in the value, because if you don't get something undefined, then that's what the limit is. So the only time you have to do tricky things is if you get undefined when you plug in the value. So for example, I'll show you what number 8 should look like. So in number 8, so this is page 66, number 8. So you don't have to always write out the problem, but I really like it if you do. It makes it easier for me to check things. So limit as x approaches -4 of x plus 3 to the 1,998th power. All right, so what you're going to do is you are going to plug in that value of -4. You're going to say it equals -4 plus 3 to the 1,998th power, and you can say that equals -1 to the 1,998th power, and then you can say, all right, since I'm taking -1 to an even power, what I'm going to get is +1, and that's why it's 1. That's what you should show. But also, when you plug in that -4, you want to justify by saying by substitution. And you can do that anytime your substitution does not yield undefined. So for example, number 10, let's do number 12 even. So number 12 says the limit as x approaches 1/2 of int x. Oh, what the heck is int x? Oh yeah, I remember. It was that thing on page 64. Okay? Page 64. So can I just plug in 1/2 to the function? Yeah, f of 1/2 is 0. I can see that from the graph. All right. So there's not much to write, except what I do want to write is it is equal to int 1/2 by substitution. Okay, you can abbreviate it if you want, and then say that equals 0. All right, so that's all you have to do for 8 through 12 is just evaluate the function, because since it says to evaluate it by substitution, you get to assume that you can. So in a number of 16 and 18, you have to say, it doesn't ask you to give it, it says explain why you cannot use substitution, okay? So for number 16, I would say for limit as x approaches 0 of 1 over x squared, you cannot use substitution because 1 over 0 squared is undefined. And I'd like you to write something like that so that you're not just copying exactly what it says in the book. Okay, so those are some of those. That'll get you up through 17. Now, I want to really look at number 18 and do a little bit more than they ask us to in number 18. So in number 18, and I guess this is sort of going to lead us into the next problem, so I will put it to the next video.